Hey guys, we're back. You know, as I say, I got this package from a one of our subscribers, and they wanted me to look this over and maybe show how it's put together and how it works, and does it really work? So I decided to take it on. Let's see what's inside this package anyway. You get a it looks like a transformer type of thing. Okay, clad board, double-sided. Okay. You have a diode, small energy diode, looks like. I'm set that here. Let's see, this is a heatsink. And here we have a regular on-off switch, it looks like. Let's set that there. We have a transistor here. It looks like 120 ohms. You can see that right there, 120 ohms. It's brown, red, brown. I don't know if that's focusing in there for a good, but anyway, that's 120 ohms. Then we have this guy here, which I believe is a 2SD882 transistor. It's a special transistor. It's not like an ordinary type. This is an NPN channel. We'll see how that really works. Oh, here's a bolt that goes to that. So I guess this transistor here goes into the heatsink with that provided bolt. And this little piece of gear, I don't know what this is going to be used for, but we'll figure it out if we even use that at all. Okay, that's what came in the package. Apparently this is supposed to be some sort of plasma generating circuit. It doesn't come with any instructions of any sort. So what I decided to do was to go back and look at the board really close, because they have it where you can put everything on this board, you know, piece by piece, and they have like a little drawing there. Let me see if I can bring you guys in on the cameras I'm using. So they have it where, you know, you can place everything on the board as it's showing here. So and then on the back, if you look really close with the lighting, you will see some traces are in here, and that's what I used to make me a drawing of sorts to determine how this actually is, the circuit works. Because like I said, it doesn't come with any furnished instructions of any sort. So, you know, it was a challenge. I didn't mind a challenge. And so what I did, I went back and I came up with, I'm just going to bring this in the picture here for just a second. I came with this drawing here, and let me just adjust something here for a second. Yeah, I came up with this drawing, and I used I probably shouldn't put this on top of this, but it's okay. I used this board to help me I used the traces on the back here to help me design I don't know, schematic, pictorial, I don't know what you want to call it, of how this circuit really should, you know, how it's really hooked up, you know, because like I said, it didn't come with its own schematic. So I'm going to go over what I found out. Let me make some adjustments here. Just a second. Let me just move some things around out the picture so I can show something. I'm just going to remove something off to the side because I really don't want to lose any parts. We don't get that many, and I don't want to smash anything. Okay, here we go. Back in the picture. Here we go. All right, there we are. Now, okay, let's go down here. What we have here, is the coil makeup of this. This is what this guy is. It's a ferrite. It has a ferrite material. It has actually it looks like 2 coils, but it's really 3 coils in this little package. As you notice, it has 4 leads. Yeah, I saw that four leads were coming out of this package, and 2 of them were thicker than the other 2. You got 2 thin ones and 2 big, thicker ones. I got the measurements, but I ain't got them with me right now. And I determined that apparently there is 2 windings on this same material here, on this same little spool. One is maybe the thinner one is wrapped first on here. I don't know how many turns, and then the thicker one is wrapped on top of it. But the board shows something peculiar about the board here. The board only has, if you was to put this together using the the board, you got holes for only 1, 2, 3. There's no fourth hole for the coil wire. So I was able to figure out that 2 of those wires are connected together to make just one. And what I mean is, okay, let's say this is the coil, the big part of this coil here. Remember I said it's got 2 thicker wires and 2 thinner wires. Well, I think that one of the thin wires are to be connected to the thick wire. See, and then you leave one thin wire loose and you leave one thick wire loose. So then all you got 1, 2, 3, and hence you're going to have 3 holes, 1, 2, and 3. You're going to get 3 holes to put them in, and that's what I figured should work. So right after that happened, so I figured this makes a coil that looks something like this inside. In general, this is more of a, if you it's more of a will help you more understand. Okay, like I said, is that you have your thinner coil winding on a ferrite material, and you have a thicker wire with a little bit more thickness wrapped on top of this one. And when they're both they're pinged together like this, let me see if I can just make that happen. There somehow you get one. If one is thin and one is thicker, they are branched together here. They're branched together right here. You get one here, and you just tie those together, and then now you got a new junction. So you got 1, 2, 3, and that's how I'm going to try to wire it into board. There's 3 units there. Okay, then this part here, this with all these little like gold windings inside, those are independent spools stacked on top of each other. They work like a multiplier. I had another circuit where I was playing with that works similar to this. It's more of a multiplier type of method of making a secondary winding, and that's what this winding is. So this side generates a decent amount of voltage, but it's amped up when it hits here, and it's amped up so high that it goes into the plasma range of arcing, versus like a stun gun would. Stun gun make a real loud pop, but they're not in that range of plasma where the light itself that's shooting between here can actually burn stuff. And that's what this particular circuit, if it's really plasma, should be able to do. It should be able to burn material or ignite stuff versus the other way. Okay, so we'll just move that aside. Now I'm just going to go over the circuit, and then we'll try to play with constructing it a little bit. Okay. It comes with a switch. Like I said, it was a single standard switch with 2 contacts. It's not a double pole, double throw, or nothing like that, or a single pole, double throw. Just a single pole switch on and off, so you can cut it on and off. That's what goes there. That's what that's going to be. This is a transistor, but not. It's an NPN transistor, but it's not an ordinary transistor. I found this transistor has capabilities of I guess creating a frequency that's needed, type of frequency that's needed to generate to excite these coils here. So you have your base, collector, and emitter in the wiring here. Then you have a diode. The cathode side going to the base, which is the negative, of course, and the anode side goes to a resistor, like a 120 ohm resistor, like this guy. It's brown, red, brown. That's okay. So that's what that is. And remember, I told you about the diode. The diode has a marking on it. Has a marking on it here. Let me see if I can put it in the camera. Oops, I can't see. Okay, I believe you can see that. But anyway, it's a little band. That band is the cathode side, or the negative side of this diode. You want to make sure you don't accidentally, when you put it in a circuit, reverse it, because it'll just stop energy. As you know, diodes conduct in one direction and block in the other. Okay, so we'll set that aside for now. Then you have the heat sink, but we'll see how that puts together too. Now, this circuit is pretty straightforward. As it shoots the juice into the coils get excited. Okay, the battery we're using is going to be like a 3.7 volt cell. I'm gonna use 18650 cell. These are pretty decent. They're rechargeable, so you can use them over and over, and that should generate enough energy for to play with this circuit. Anyway, the one of the coil that we combine will go to the positive of the power, and then the negative of the battery will reach around through the switch to the emitter. And then, as you know how transistors work, when you apply energy to to the two poles here, it'll make it like a switch itself. But this transistor, it will make like a 555 timer astable mode pulsing, but it'll do it really rapid. And with that rapidness, it causes a AC type of energy here. And as we know, it'll go through the ferrite material into the coil, to the bigger coil, which is this multiple coil multiplier here, and that should bring out the nice arc. Okay, so that's pretty much going to be it far as this picture is go. I went ahead after I got this in, and I ordered another one so I can take it apart, of course. And I did just that, and I'm going to show you what I did with that. I took this one apart, and I put it back together too, though. But inside here, I found that there were two coils inside here, as I said. And what I have to do to make this get into the, because I'm gonna construct this on a breadboard. So that's why I had to have these kind of pins here, because I couldn't just stick the bare wire into the breadboard. I'm not going to assemble the circuit on this because it's too tiny. Plus, it doesn't spread out enough to understand. But so to help you understand how it's wired, we're going to do it on a breadboard, and all that is one of these guys. We're going to assemble everything on here, and of course you see how much bigger it is compared to the little clad board you get, and that will help visually understand it a little bit better, I feel. So that's what we're going to do. Right now I'm going to try to solder these. I just twisted them on right now. I had to scrape away some of this enamel that was on these wires, because these wires come enameled, right? And scrape away some of that, and I just twisted the little conductors onto here. I got to solder them though, so they'll have a better connection. So we're going to solder these in a moment, and then we're going to try it out. So this is how it was at first when I got it, and this is the one. This is an identical one, but it is just got the leads on. So we're going to finish constructing these leads on here, so they won't move around, and they will also make good contact. So I'll bring you back in a moment when I'm ready to do that. All right, so we're back. We want to try to, as I say, I want to solder these tips right here onto these the ends of the coil wires, because I'm not going to be able to stick those into the breadboard by itself without something stronger than that. So that's what we're going to do right now. First, I need to try to get some of this enamel off the end of this wire. There's a lot of enamel that they put on it when they made this coil, and you have to scrape it off or either burn it off. I usually try to scrape some of it off. I'm just going to scrape a little of this paint material crap off, and let's get some of it off so I can solder, and you can get connections to it. These wires are very thin, so you have to be very careful if you want to go do this. Don't cut into the wire, because they are somewhat fragile, I guess you might say. I'm just going to scrape it just to get it to the shiny part. Once I get to the shiny part, I know that I got most of the enamel off, and especially on this one here that I twisted together, because even though I twisted together, it's not really making it's not really conducting together as one until I scrape the enamel away. So now we're going to go ahead and drop this into a pair of helpers here, I call it. And I have some safety glasses here. I'm going to put on these just to keep things from popping in my eye. Excuse me, goodness gracious. Anyway, something's got me sneezing over here. All right. Yeah, so we're going to put this into the little hand thing here. I'm going to do that. And I'm going to just straighten it out a little bit. I'm going to try to tin these tips first before I do anything else. And tinning is just mean I'm just going to put a little solder on this wire to make it easy to operate. When you're doing this, you want to not be downwind of the fumes that's coming off of here, because I don't know how dangerous it is, but I imagine it got some danger behind it. So anyway, that's one tin. I just got one of them. I'll do two more. I use these little handy hands because it's hard to hold the wire, solder, and keep everything clean at the same time. But let's see what we can do here. Just get a little bit. I just want to lightly tin, especially this one, because this one is twisted, just twisted together. But I definitely want that to be have a good connection. So let's see, one more here. That'll work. And I gotta be very careful with these wires because they could break, and then I would have to unwind some of the coil to get more out of there, and I don't want to do that. Just put a little bit on there. Okay, that's that. I'm gonna stop while I'm ahead on that one. So let's take this out. Now I'm going to also tin these guys. This is a stranded wire with a stiffer conductor. That's why it's important for me to use this, because the bare wire itself is not strong enough to push through the breadboard like it's going to need to be. So I'm going to tin these as well. Okay, that's that. That's one. I think I got three of these to do. I'm going to try to do it as neat as possible, because your final result of it'll show if you're a little bit neater with it. So let's just get some tin on there. I probably should have dipped this in a little solder. I mean, a little rosin core stuff that will help it the solder to flow better. I forgot to get that out, but that's all right. So far, so good. All right, one more here. Here we go. And that'll be all I'm gonna put on this one now. What I'm gonna attempt to do now is actually put them to each wire. I don't know how I'm gonna do this, but let me see. Let's see. First, I'm gonna see if I can just connect them slightly by twisting together, and then heat it up. I believe that'll work. Okay, let me try that. Let me see. Attach it now. There. Don't go nowhere. And okay, let's see how this looks in there. Okay, that is on there. Guess that's rather strong. Okay, it's one. And this one here. So all I'm doing now is just putting the leads onto the coil wires so that we won't have any problem when it comes to hooking it up. Connection won't be an issue. Let's see. Let's put a little more off of this roll. All right. And what's this thing doing? All right. Got it. I'm having to clean the solder iron between making these joints, because the solder, as it heats up, it'll stop being able to bond stuff for some reason. I think it burns so much, and then it just don't work no more. So far it's okay. Let's try to do this one. It's be tricky. Let's see. Ooh, it's hot. Okay, let's see. I hope you guys can see this. I'm not really paying attention to the monitor, but I believe you are still able to see what I'm doing. Okay, so that's it. Now, we have leads on each one of these. Remember, we have that one we bonded together, the two wires, the thick one and the skinnier one. Moves out the way. And then we have a thin wire and a thick wire. That's our three connections that we needed. And let's set that up here. This is the breadboard I was talking about. Oh, you know what? I think I'm gonna do one more thing. I'm gonna put some tinning on these tips, because this is where the spark gap is going to be, and it needs to be as strong as possible. So I'm gonna try to get this spark gap to have some sort of terminal stuff on it. So I'm gonna tin that just at least a little bit. Let's see. All right. I don't know. All that's going to do is make the spark be able to jump across the gap to this instead of jumping across the gap to the installation. Okay. Alright. That should do it. Alright, so our next phase is going to be actually assembling these components onto a breadboard. So I'm going to bring you back because I got to empty the memory card in my GoPro. It's going low, so I don't want it to run out. So I'll be right back in a moment. Connection. Now I'm going to put a 120 ohm resistor. It's 120 ohm. That is brown, red, brown. 120 ohms, right? Anybody see that? You can see that brown, red. Okay, now so I'm just going to stick that into the breadboard as well. Now that's exactly in series. So the diode is going from base, the cathode side, of course, and then it's going, the anode side is connected to the front of the resistor, the 120 ohm resistor. The other end of the resistor needs to go to one of the skinny wires, or let me see. Yeah, I'm gonna put a jumper from here to this skinny wire here. So I'm just going to do that right now. I'm just going to use a jumper. I'm going to try to put one from here to there. Here. Okay, you can't see it because it's like white. It's colored white, so you might have a hard time seeing it on the camera here. So. Then, okay, so that part is hooked up. Now I'm going to hook the other end of the coil, which is this guy here. I'm gonna bring that one to this track here, which is the collector of the transistor. I'm gonna hook a jumper from there. Let's put a jumper on here. Let's see. So I want jumper to go from the collector here to this guy here. Let's see if that's coming out right or what. Okay, so the collector it should go to the big wire, right? One big wire. Okay, so as I'm trying to compare this to the drawing I made and make sure I wired it right. But we just connected the bigger diameter wire to the collector. The skinny diameter wire went straight to the resistor, which went to the diode, which went to the base. And the final one is just going to be the positive terminal of the voltage potential that I'm going to add. And then the other negative part of the voltage is going to be from the switch. So we're going to see if I can rig that up. I'm going to bring in some power. This is a 18650 battery I salvaged from a laptop battery pack or whatever. And this is positive here, and this is negative here. So we're going to connect up. But first, before I do that, I need to hook the switch into the system. Right now we don't have no switch, but I'm finna to have one by putting a jumper from the emitter of the transistor, which I made jump across the threshold here. I'm just gonna push it there, and I'm gonna use one side of the switch, like so. I believe do it like that. I'm gonna try to bend this down so you can see how it's connected a little bit better. And bring it to the camera just for a moment. Okay, and then my front camera. Okay. Alright, there we go. Hopefully it's not looking confusing to you guys out here. But so far we have the switch going to the emitter of the transistor terminal. And then we have the collector going. The collector pin is this one here, which I jumped across, so it'd be the yellow wire. It's supposed to go to the thicker wire on one of the coils, which I did. Okay, I'm getting an alarm from where. Okay. Okay. The bigger wire here is from which I made here, that's connected together with a thin wire and a thicker wire. That goes to a positive. So we're gonna hook some voltage up. see if I get a jumper. But I had enough jumpers up here on the table. Okay, just a second, everybody. I just gotta locate a jumper. Okay, I might have to pause just for a moment because I gotta get a jumper. I don't see one in range and I need to get it. Okay, so I'm just gonna pause everybody right now. Hang tight. Okay, I found some jumper wire, so I'm going to try to connect the switch up, but instead of hooking this little bitty one up, the one I was intending to hook at first, the leads kept jumping out of the board, so that wasn't going to make a good connection for me. So I'm just going to get rid of that, and I'm going to incorporate the one that came in the package. Remember this little red guy that came in the package? So we're going to incorporate this instead. So I'm just going to hook that into the circuit, coming from the negative pole of the battery and going to the emitter of the thing. Now, what's supposedly supposed to happen if I push this switch on, at this part here, it's supposed to radiate. Let's see what happens. Hopefully it's good. No, wait, let me see. Sometimes you have to move these terminals close because the gap is not that big for this thing for some reason. It's like really small gap. So let me see if I can get it to radiate across. Okay, what's holding up the game? Let's see here. That's connected. That's connected. Okay, hang on. Let's do something else. Let's put a different battery in, maybe. Let's see if that might change the game up a little bit. Let me put this one in there. So I don't know how much charge is on there. I didn't test it out yet. I don't want to get shocked by playing with this in here, but I gotta do that. Let me see. It's very interesting here. I don't know why it's not energizing. It doesn't seem to be. I looked at all my wiring. Touch a couple things here. Okay, I'm hear it. I wonder is the connection here is bad or good. I'm not certain. Oh, this is odd. Okay, what I got to do, I can hear it arcing, but I'm gonna try to squeeze some of these. Even when I soldered these, I was hoping that it would grab onto the metal really well, but I might be having some trouble with that. No, it's arcing now. Let's see what happens. There we go. Okay, so it's working there. It just was tiny. You can see that little light shooting across. I'm gonna shut it back off. And then watch this little spot right here, one point right here. Watch this. When I hit the switch, it's going to hopefully generate. Let me see, bring it in close. I shouldn't have to bring it in that close, though. This is hilarious. Okay. Hang on. Let's see. Check the battery. This is really weird. Okay. So this is what happens in real time when you're shooting videos, guys. Sometimes you think something's going to go the way it should, and then it just don't, Things happen, but you're seeing it as I'm seeing it. And I'm going to have to figure it out really fast. I'm checking all the joints while I'm moving things around. Look, I'm trying to make sure every joint, okay, is located. The problem is here. It looks like it's there. Okay, found it. So what I'm going to do, it looks like this little jumper wire is not doing its job. So I'm going to pull this out. And I'm going to go direct with the switch here to pop it in there. Because I was trying to jump across, but there's no need to. I really don't have to. So I'm going to go ahead now. And when I hit it, there it is on. See, it's on now. So the problem was that jumper. Now, what I want to show you is what that little thing, that little light that's shooting across there can do. Watch carefully. It whistles a little bit as it's doing this thing, but just watch. The energy is so hot that it's going to ignite this little tip here as soon as I keep it in the game. Wait, let's see here. It's radiating a plasma-like energy onto it. And it's actually igniting this tip. As you can see, it has ignited it, So I'm going to do this in here. It'd be better probably. A little bit, fluff it out a little bit. And as you can see, there's a fire there. You see, so it ignites the flame, the material once it gets hot enough. And that little light there, you don't want to touch that with your finger either. That's the other thing. That's what I meant to tell you. You don't touch that with your finger, but it will light up stuff, you know, because it's a very hot energy. So I'm just gonna put that out for a second so I don't start no fire. But yeah, so this is how this works. So essentially, you know, they use these. You can use these kind of circuits in lighters. You know, like they have cigarette lighters that are made with these type of spark gaps like this. But with this here, the way for me breaking it down, it kind of gives you a small understanding of what's inside one of those things. But I got even something better that I scouted around on Amazon and found was this little device. This here also is a more robust flavor of this circuit we just built. You see how it's all sealed up. You can't see what's in it, but you know, they don't want you to know what's in here. But primarily, what you see here in front of you is how this is made. But let me show you the power behind the power of this compared to this guy. I'm just gonna bring the leads just in a little bit close. I'm gonna move this one back out the way. I'm gonna borrow the battery from here because I know this battery is working good. I'm just gonna borrow that back. I'm just gonna scoot this to the side just at least a little bit. Bring this one in front, and I'm gonna show you something a little bit more exciting than that circuit. Well, I never put that circuit together before. I thought it was gonna be a bigger thing, but it does work functionally, you know, for like a demonstration. But it's not really what I would consider very powerful or something that I would use. But this one here I have in my hand is a whole lot more going on. So I'm going to show you in a second. I'm just going to get the wires where I want it. And we're going to watch how big the gap on this one. You notice how far apart this gap is. And make sure you can see that really well. The gap doesn't have, for this module, don't have to be that close. So let me make sure my cameras are on. Okay, so watch the spark gap. I want to do this without, as you can hear, it's very loud, and when you come in, it's almost instantaneous ignition of the flammable material. So, and the spark gap is like I said, it's very loud and faster than the one we just built on the board. So let me put that out. And it whistles quite loudly. Now this particular one will shock you if you touch that with your hand. You won't feel too good behind that one, but that's not the purpose of this video. But I just wanted to show you that you know, I'll leave a link to this guy here on Amazon. You can get this other one, Chinese made one that they have in kit form if you want to learn the dynamics behind how it's made, like I just showed you here. And if you want, you can even, I'll leave a picture of this schematic that I drew out so you can wire it up once you get the kit, you know, on your own breadboard. You can practice wiring it up. Now don't forget, even though it was a tiny gap here, the potential to burn or shock you is still about the same, because they're both putting out in a plasma range of energy. So you don't want to be messing with that hot end right there with your fingers or anything like that. So yeah, so I think that might do it far as showing you how this works. I'm going to, like I said, I'm going to leave a link to some of these, to this other device. This is a more robust one. And I'll leave a link to this one that you can get as a kit so you can wire it up yourself. And I think that might be about it. So until next time, everybody stay safe, and bye-bye.